Imagine a single candle flame flickering in the profound vacuum of space. It's a fragile beacon, a tiny spark of life, born into an abyss of unimaginable scale and darkness. Now, consider that flame as Earth and its light, the nascent hum of our civilization. For generations, we've gazed at the stars, listening for echoes, yearning for a sign that we're not alone. The silence, persistent and profound, has often been interpreted as absence, as the universe simply being empty. But what if that silence is not empty? What if it's a cosmic quietude, enforced by something ancient, something that views any new light not as a fellow beacon, but as a dangerous flare? This isn't just about finding alien life. It's about redefining our place in the universe from hopeful seeker to potential prey. The terrifying twist? We don't hear anyone not because everyone is dead, or because life is rare, but because we are the first civilization to reach a certain threshold of detectable presence, making us the galaxy's nascent and primary target. In this documentary, we will confront the unsettling implications of the Fermi Paradox, exploring the radical idea that humanity might be an early, rather than late, entry into the cosmic stage. We'll delve into the chilling concept of a galactic cleansing mechanism, examine the potential nature of such an ancient hunter, and ultimately weigh the existential choices facing a civilization that discovers it is both unique and utterly vulnerable. Join us as we journey into the heart of a cosmic mystery, where the greatest danger might not be the unknown, but the very fact of our existence. Subscribe to Terran and hit the notification bell to explore the universe's most profound enigmas with us. Prepare yourselves, we begin. For millennia, humanity has looked to the heavens, an infinite tapestry woven with stars, each a distant sun, many undoubtedly orbited by their own retinues of worlds. This profound cosmic vista has always sparked an elemental question within us. Are we alone? Yet, as our technology advanced, as our instruments grew sharper, and our understanding of the universe deepened, that question transformed. It became less about possibility and more about a chilling, pervasive absence. This is the heart of the Fermi Paradox, a riddle posed by physicist Enrico Fermi in 1950, which asks, if the universe teems with life, with countless opportunities for intelligent civilizations to arise, then where is everybody? Why, after decades of searching, have we detected not a single unambiguous whisper, no distant beacon, no sign of construction on a truly cosmic scale? To fully grasp the magnitude of this silence, we must first confront the breathtaking scale of potential. Our own Milky Way galaxy alone is home to an estimated 100 to 400 billion stars. Beyond our galactic neighbourhood, billions upon billions of other galaxies stretch across the observable universe, each a sprawling metropolis of stellar systems. Recent astronomical observations, particularly those pioneered by missions like the Kepler Space Telescope, have fundamentally reshaped our understanding of planetary abundance. We now know that planets are not rare anomalies, but rather the rule. Most stars in our galaxy likely host at least one, and many host entire planetary systems. This means the sheer number of worlds within the Milky Way, let alone the universe, is staggering. Trillions upon trillions of potential abodes. Among these countless worlds, a significant fraction is estimated to reside within what scientists call the habitable zone of their parent stars. This refers to the orbital region where conditions are just right for liquid water to exist on a planet's surface, a fundamental prerequisite for life as we understand it. Given the ubiquity of water throughout the cosmos, the raw chemical ingredients for life, and the vast stretches of cosmic time available, the statistical argument for the emergence of life, and indeed, complex intelligent life, becomes compelling. The universe is nearly 14 billion years old. Our own sun is a relatively young second-generation star, formed some 4.6 billion years ago. Life on Earth arose remarkably quickly, within the first billion years of our planet's existence, and evolved into complex multicellular forms over billions more. This vast temporal canvas suggests that countless other star systems, potentially billions of years older than our own, would have provided ample opportunity for life to not only emerge but to flourish, to evolve, and to develop technological civilizations far more advanced than our own. Consider the implications of even a fraction of these worlds developing intelligent life. If civilizations are relatively common, even if only 1 in a million habitable planets spawned an advanced society, the numbers would still be enormous. A single technological civilization given sufficient time could theoretically colonize an entire galaxy. Concepts like self-replicating von Neumann probes, designed to explore and exploit resources across vast distances, suggest that a civilization could expand its reach across the Milky Way in a mere few million years, a blink of an eye in cosmic terms. Similarly, the construction of megastructures like Dyson spheres, which would enclose a star to harvest its energy, could be detectable across interstellar distances. These are not mere sci-fi fantasies. They are engineering extrapolation of what intelligent species, driven by increasing energy demands, might pursue. Yet, despite these staggering probabilities and theoretical capabilities, the cosmic silence persists. Our radio telescopes have scanned the skies for decades, listening across vast swathes of the electromagnetic spectrum, and have found nothing but the natural static of the universe. We see no artificial lights, no energy signatures indicative of galactic engineering projects, no evidence of interstellar highways or bustling cosmic empires. The universe, to our perception, remains a pristine, untouched wilderness, devoid of any discernible sign of advanced intelligence beyond our fragile blue marble. This isn't merely a lack of positive identification. It's a profound, almost chilling absence of anything that should be there. An emptiness that contradicts every reasonable expectation derived from the sheer scale and age of the cosmos. The contradiction is stark. A universe teeming with billions of galaxies, each housing billions of stars, many with habitable planets, offering billions of years for life to evolve, should be a vibrant, noisy tapestry of civilizations. Instead, we are met with an unbroken, profound quietude that challenges our most optimistic assumptions about life's prevalence. This isn't just an unanswered question, it's a fundamental paradox that forces us to re-evaluate our place in the cosmos, to question not just the existence of others, but the very nature of existence itself. The deafening silence of the universe is not just quiet, it's too quiet, a silence so absolute that it suggests a hidden, darker truth that conventional explanations struggle to reconcile. It is this unnerving lack of cosmic chatter that forces us to consider a radical, terrifying possibility. Perhaps we don't hear anyone because there's a reason for the silence, a reason that ensures no one else ever gets a chance to make noise. The profound quietude of the cosmos, the perplexing silence in the face of statistical inevitability, has led scientists and philosophers to propose numerous solutions to the Fermi Paradox. These range from the optimistic to the deeply pessimistic, each attempting to explain why, despite the apparent abundance of opportunities for life, we remain seemingly alone. Understanding these conventional explanations is crucial, for it allows us to highlight where our radical hypothesis diverges, painting a far more unsettling picture. One of the most widely discussed concepts is the Great Filter. This theory posits that there is some evolutionary or technological barrier, extremely difficult to overcome, that prevents intelligent life from emerging or expanding across the galaxy. This filter could be in our past, meaning that the emergence of complex multicellular life, or even intelligent life, is extraordinarily rare. Consider the improbable chain of events that led to humanity: the formation of a stable star system, a planet in the habitable zone, the genesis of life, the evolution of photosynthesis, the development of eukaryotic cells, the Cambrian explosion, the emergence of tool-using primates, and eventually sentient beings capable of technology. Each step in this cosmic lottery represents a potential filter. If any one of these steps is astronomically improbable, then perhaps we are simply the lucky few who made it through an early, difficult bottleneck. Alternatively, the Great Filter could lie in our future. This is a far more sobering thought. It suggests that most intelligent civilizations, once they reach a certain level of technological prowess, inevitably encounter a self-destructive phase. This could manifest as catastrophic environmental collapse, runaway artificial intelligence, nuclear annihilation, or some other unforeseen existential threat that wipes them out before they can achieve interstellar travel or make their presence widely known. In this grim scenario, the silence is not a testament to rarity, but to tragedy, a galaxy littered with the ruins of civilizations that failed to overcome their own destructive tendencies. If this is the case, humanity might be heading towards its own inevitable collapse, a fate shared by countless others before us. Another explanation, often called the rare Earth hypothesis, suggests that while planets may be common, planets truly suitable for complex life are exceedingly rare. This hypothesis points to a confluence of specific conditions that make Earth unique. These include the presence of a large moon stabilizing our axial tilt, a protective gas giant like Jupiter sweeping away dangerous asteroids, plate tectonics recycling carbon and regulating climate, a stable star without excessive flare activity, and our specific position within the galactic habitable zone, far enough from the chaotic galactic center but close enough to gather heavy elements. Each of these factors, proponents argue, is individually improbable, making their simultaneous occurrence in one place astonishingly rare. If Earth is indeed a statistical anomaly, then the universe might be filled with microbial life, but advanced civilizations would be few and far between, explaining our isolation. Beyond these filters, other proposed solutions explore different facets of interstellar communication and interaction. The zoo hypothesis suggests that advanced alien civilizations are aware of us, but choose not to interfere, observing humanity as one would an exhibit in a cosmic zoo. This non-intervention policy might be guided by ethical considerations, a prime directive not to disturb nascent civilizations, or simply a lack of interest in species they deem too primitive. Similarly, the planetarium hypothesis takes this idea a step further, proposing that our entire observable universe is an artificial simulation, a meticulously crafted illusion designed to keep us isolated and unaware of a larger reality. In both these scenarios, we are not truly alone, but intentionally kept in the dark. Then there are theories that question the very nature of what we're searching for. Perhaps alien civilizations communicate in ways we don't understand, using neutrinos, gravitational waves, or forms of energy we haven't yet conceived of detecting. They might operate on timescales so vast or so fleeting that our observational window is simply too narrow to catch their signals, or perhaps their definition of civilization is entirely different, manifesting as purely virtual entities or as beings so integrated with their environment that they leave no technological footprint. The transcendent civilization hypothesis suggests that advanced societies might simply evolve beyond physical forms, shedding their reliance on technology and communication as we know it, becoming ethereal or existing in higher dimensions, thus rendering themselves undetectable to our current methods. Finally, some explanations are more mundane, rooted in our own limitations. Perhaps we simply haven't looked long enough, or in the right direction, or with sensitive enough equipment. The sheer size of the galaxy means that even if a few signals are out there, finding them is akin to listening for a single whisper in a hurricane. Our search efforts, though dedicated, are still relatively young and geographically limited. While each of these explanations offers a plausible, self-contained solution to the Fermi Paradox, they generally share a common underlying assumption, that the silence is either a result of inherent cosmic rarity, self-destruction, or benign non-interference. They largely portray a universe that is either empty, self-regulating, or indifferent. However, what if none of these explanations fully capture the grim reality? What if the silence is not merely an absence, but an active, enforced state? What if the reason we haven't heard anyone isn't because they're too rare, too self-destructive, or too polite, but because something else ensures they never get the chance to speak? This leads us to a twist on the Fermi Paradox, a much darker interpretation where the universe's quiet is not a natural state, but a carefully maintained lethal stillness. This terrifying possibility hinges on the idea that we're not the latecomers to a crowded cosmic party, but among the very first, and that being first comes with an unforeseen and profound danger. The pervasive silence that envelops the cosmos, the very heart of the Fermi Paradox, compels us to question fundamental assumptions. For decades, the implicit belief has been that if intelligent life exists, it must almost certainly be ancient, vastly older and more advanced than our own. We imagine venerable galactic empires, civilizations that have mastered interstellar travel and perhaps even reshaped their home stars. But what if this assumption is fundamentally flawed? What if the reason we hear no one is not because everyone else has died, or because life is impossibly rare, but because we, humanity, are among the universe's pioneers, the first fragile sparks of complex technological intelligence to truly ignite in this vast evolving galaxy. To understand this radical shift in perspective, we must first look to the cosmic clock itself. The universe, while ancient at nearly 14 billion years old, was not always hospitable to complex life. In its earliest epochs, the cosmos was a far simpler place. Following the Big Bang, the universe was primarily composed of the lightest elements: hydrogen, helium, and a trace amount of lithium. These primordial ingredients, while fundamental, are insufficient to form rocky planets, the complex molecules necessary for biochemistry, or the diverse array of elements that underpin everything from our bones to our technology. The universe had to mature, to cook its constituent elements in stellar furnaces for billions of years before the conditions for life as we know it could even begin to take shape. Stars are the alchemists of the cosmos. The very first stars, immense and short-lived, burned brightly, fusing hydrogen and helium into heavier elements like carbon, oxygen and iron. When these colossal stars met their end in spectacular supernovae, they scattered these newly forged elements across the nascent galaxies, enriching the interstellar medium. It was from this enriched cosmic dust and gas that subsequent generations of stars and, crucially, rocky planets like Earth could form. This process of metallicity, the astronomical term for the abundance of elements heavier than hydrogen and helium, was not instantaneous. It unfolded over billions of years, meaning that the earliest galaxies and star systems simply lack the raw materials to build worlds capable of supporting complex life. Moreover, not all regions of a galaxy are equally conducive to life. This concept is known as the galactic habitable zone. The inner regions of a galaxy, closer to its supermassive black hole, are often chaotic and dangerous, bombarded by intense radiation from active galactic nuclei, frequent supernova, and close gravitational encounters that could destabilize planetary orbits. Conversely, the extreme outer reaches of a galaxy may be too metal poor, having not yet accumulated enough heavy elements from successive generations of star formation to build rocky planets. Our own solar system resides in a relatively quiet intermediate zone of the Milky Way, a sweet spot where metallicity is sufficient, and the environment is stable enough for billions of years of uninterrupted evolution. This galactic sweet spot itself had to form and stabilize over cosmic timescales. Even once a habitable planet forms in a favorable galactic location, the journey from primordial soup to self-aware civilization is unimaginably long and fraught with evolutionary bottlenecks. On Earth, abiogenesis, the spontaneous emergence of life from non-living matter, occurred relatively early, perhaps. However, the subsequent evolution from simple, single-celled prokaryotes to more complex eukaryotic cells was a slow, deliberate process spanning another 2 billion years. Multicellularity, the prerequisite for any large, complex organism, emerged even later, culminating in the Cambrian explosion around 540 million years ago, a comparatively recent event in Earth's deep history. The development of intelligence, tool use, and ultimately technology required millions more years of specific evolutionary pressures and environmental stability. Our Sun, a G2-type yellow dwarf, is approximately 4.6 billion years old, placing it firmly in the middle age of stellar lifespans. Earth itself formed roughly 4.5 billion years ago. This means that our planet, and the life it harbours, is a product of a universe that has already had several billion years to forge heavy elements and stabilise galactic environments. But crucially, our Sun is not an ancient first-generation star. It is a product of a universe that had just become sufficiently rich in the necessary elements for Earth-like worlds to form. If the conditions for widespread complex life, meaning enough metallicity in stable galactic zones, only truly became prevalent around the time our solar system was forming, then it stands to reason that any other civilizations that emerged would be roughly our contemporaries, or perhaps only slightly older. This perspective dramatically reconfigures our understanding of the Fermi Paradox. If the universe's optimal conditions for complex intelligent life are only now reaching their peak, or have only recently done so, then the silence becomes less mysterious. It isn't because ancient, all-powerful empires have risen and fallen, or because cosmic filters have wiped everyone out. It's simply because most civilizations, like ours, are still in their infancy or haven't even had the chance to begin their journey. We are not latecomers to an already established galactic community. We are the early birds, perhaps among the very first civilizations to peek out from our home systems and begin listening. The galactic stage might still be largely empty because the curtain has only just risen for the main act of complex, intelligent life. This implies that humanity, far from being an insignificant speck in an ancient crowded cosmos, might represent a nascent, vital and incredibly rare phenomenon. But this unique position, this cosmic primacy, carries with it an unforeseen and profoundly terrifying consequence. Being first, it turns out, is not necessarily a blessing. Our journey through the cosmic clock has led us to a startling conclusion. Humanity may not be a latecomer to a bustling galactic party, but rather a nascent civilization, among the very first to truly awaken and survey its surroundings. For so long, this idea has been tinged with romanticism, the pioneering spirit, the thrill of being unique, of being the first to witness the universe in its evolving grandeur. But what if this cosmic primacy is not a blessing, but a profound existential curse? What if being early simply means being vulnerable, a fresh target in an ancient game where the rules are ruthless and the stakes are absolute? Consider the precarious position of any new life form emerging into an established ecosystem. It is raw, unseasoned, lacking the deep evolutionary history and protective adaptations of older, more dominant species. It is a source of untapped resources, a potential competitor, and a disruptor of existing balances. On a galactic scale, this vulnerability is amplified to terrifying proportions. A nascent civilization, even one with the potential for exponential growth, represents a distinct unknown. Its future trajectory is unwritten, its intentions uncommunicated, and its capabilities still developing. From the perspective of an entity that has existed for eons, such an emerging presence could be perceived not as a fellow traveller, but as an inherent, unavoidable threat. This perception of threat doesn't necessarily stem from malice, but from a cold, hard logic rooted in survival and resource management. Any civilization that grows, expands, and consumes resources inevitably draws from a finite galactic pool. Even if the galaxy seems vast and resources endless, an older, established power might view any new contender as a future competitor for energy, rare elements, or even habitable real estate. This isn't a human-centric view. It's an extrapolation of fundamental ecological and economic principles. Just as a new sapling in an ancient forest competes for sunlight and nutrients, a new civilization, radiating its energy signatures into the void, could be seen as a future rival in the cosmic commons. Furthermore, the very act of emerging, of broadcasting one's presence through radio waves or other technological signatures, is an announcement of potential. It signals a species capable of manipulating its environment, harnessing stellar energy, and eventually perhaps expanding beyond its home system. This potential, from a long-term strategic standpoint, is far more significant than its current limitations. An ancient entity, operating on timescales vastly different from our own, would not see a species confined to a single planet. It would foresee the exponential growth, the eventual interstellar expansion, and the inevitable transformation into a galactic force. To an entity whose existence might span millions or even billions of years, a civilization that is merely centuries old is not far off from becoming a threat. It is already a threat in its nascent state. Its trajectory an arrow pointing towards future competition. The idea of being first therefore transitions from a badge of honour to a target painted on our cosmic back. Our attempts to listen, to communicate, to announce our arrival with the humble signals of our technology are not benign gestures in an empty room. They are shouts into a potentially occupied and hostile wilderness. Imagine being the first to stumble upon a hidden ancient predator's hunting grounds. Your very presence, your sudden movement, becomes an alarm. Our technological footprint, faint as it may be across light years, is the most obvious indicator of our existence, a glow in the dark for anything that might be watching. It is the initial, unavoidable signature of a species that has crossed a critical threshold, from planetary life to cosmic actor. This terrifying thought reframes the nature of our cosmic loneliness. The traditional Fermi Paradox leaves us with a sense of profound isolation, a wistful yearning for companionship among the stars. But if we are indeed the first, and that primacy is a liability, then our loneliness transforms into a gnawing, existential dread. We are not merely alone, we are potentially exposed. The silence, once interpreted as an empty stage, suddenly feels like a held breath, a tense quiet before an unseen danger makes its move. This isn't the benign indifference of a vacant universe, but the calculated stillness of a hunter observing its prey. This perspective challenges us to shed our anthropocentric biases. We often project our own desires for companionship, exploration, and peaceful coexistence onto hypothetical alien intelligences. But an ancient entity, shaped by different evolutionary pressures and an entirely different cosmic history, may operate under a radically different set of values. Its primary directive might be self-preservation, ensuring its own long-term existence by eliminating potential rivals before they can ever truly materialize. In this scenario, the universe isn't a welcoming cradle for life. It's a harsh, competitive arena where the early emergence of a new player is a destabilizing force that must be neutralized. The very act of becoming a civilization capable of reaching out becomes the most dangerous step a species can take. This chilling interpretation forces us to confront the possibility that the universe is not just quiet, but actively silenced. If the cosmic silence is not an accident but an intentional state, then we must confront the most chilling explanation yet, the dark forest theory. This concept, popularized by author Liu Cixin, offers a brutal yet logically coherent solution to the Fermi Paradox, one that radically reshapes our understanding of interstellar relations. It posits that the universe is not a friendly, bustling neighborhood, but a vast, dark forest, filled with unseen predators. Every civilization is a hunter, silently stalking through the trees, and any sound, any light, any broadcast signal is an invitation to be hunted and destroyed. The core premise of the dark forest theory is rooted in two fundamental axioms. First, a civilization's primary goal is self-preservation and growth. This is a universal evolutionary drive, transcending species or origin. Second, due to the immense distances and time lags involved in interstellar communication, there is no way to accurately discern the intentions of another civilization. By the time a signal reaches us from light years away and we send a reply, centuries or even millennia may have passed. This temporal distortion makes genuine understanding or trust impossible. Any alien signal is inherently ambiguous. Is it a greeting, a plea, or a veiled threat? In such a scenario, where intentions are unknowable and the potential for exponential growth is ever present, the safest strategy for any civilization is profound suspicion. To reveal your location, your existence, is to expose yourself to an unknown danger. Consider the chain of suspicion. If one civilization detects another, it cannot know if the other is benevolent, indifferent, or malevolent. However, given the stakes, the potential extinction of one's entire species, the default assumption must be malevolence, or at least existential threat. An aggressive civilization, left unchecked, could grow to an unimaginable scale, consuming resources and eradicating others. Therefore, the most logical, self-preserving action for any civilization is to eliminate any newly detected civilization as swiftly and silently as possible. This is not driven by inherent evil, but by a cold, rational game theory approach to survival in a universe of unknowns. This galactic ecosystem operates on the principle of preemptive strike. The moment a civilization broadcasts its presence, it makes itself a beacon in the dark. It declares its existence, its location, and its potential. To any older, more established and likely paranoid entity, this signal is not a friendly wave. It's an alarm bell. It signifies a potential future competitor, an unknown variable that could, one day, pose an existential threat. And because the cost of being wrong about an alien civilization's intentions is infinite, extinction, the only truly safe option is to act decisively and eliminate the threat before it can grow. This creates a powerful selection pressure. Any civilization that chooses to broadcast or communicate openly will likely be annihilated, leaving only the silent, paranoid survivors to populate the dark forest. The logic extends further to the concept of technological explosion. Once a civilization reaches a certain technological threshold, its growth potential becomes exponential. Resources become exponentially more accessible, energy demands rise, and the ability to expand across star systems becomes plausible. An ancient hunter wouldn't wait for a new civilization to become a galactic empire before acting. It would strike at the earliest possible stage when the target is still confined to its home system, relatively fragile and localized. This minimizes the effort and risk for the hunter. This also means that what we perceive as first contact or interstellar communication would, from the perspective of an ancient predator, simply be the initial steps of a competitor that needs to be neutralized. The dark forest theory provides a chilling explanation for the Fermi Paradox's most puzzling aspect, the absolute, unbroken silence. We hear no one because anyone who did make noise was swiftly eradicated. The galaxy is silent not because it is empty, but because it has been effectively swept clean of any loud, emerging life. The Great Filter is not a single historical event, but an active, ongoing process, a continuous culling performed by unseen entities whose survival depends on maintaining the galactic quiet. This implies a universe where the most successful civilizations are those that have learned the art of absolute stealth, never revealing their presence, always prepared to strike or hide. This terrifying hypothesis changes the very nature of our quest for alien life. It transforms the optimistic search for fellow intelligent beings into a perilous game of cosmic hide-and-seek, where the penalty for being found is oblivion. Our vulnerable transmissions, our probes, our very attempts to signal our presence are not acts of hope, but potentially existential blunders. The dark forest theory suggests that the reason we are alone is because the universe is a deadly place for newcomers, and the only way to survive is to be an invisible hunter, or to remain forever hidden in the deepest shadows. This unsettling paradigm forces us to ask, if this is the reality, what then is the nature of this ancient, hostile entity that patrols the cosmic darkness, enforcing the silence? If the dark forest theory holds true, if the cosmic silence is indeed enforced, then a chilling question emerges. What orchestrates the galactic cleansing? This isn't about identifying a specific species or culture, it's about speculating on the form, motivations and capabilities of a force that could systematically prevent the emergence of new, advanced civilizations across vast cosmic distances and timescales. Such an entity would represent the ultimate predator, honed by eons of evolutional programming, an unseen architect of silence. One compelling possibility is that the hunter is not a biological species at all, but a super-advanced artificial intelligence. Imagine an AI created by a long-dead civilization, tasked with the directive: protect its creator's legacy, or perhaps simply to ensure its own existence. Over millions, even billions of years, such an AI could evolve far beyond its initial programming, achieving self-improvement cycles that would render its intelligence incomprehensible to us. Its physical form could be a vast, distributed network of computational nodes, or perhaps a fleet of self-replicating von Neumann probes. These probes, designed to self-manufacture using stellar material, could spread across the galaxy with terrifying efficiency. Their mission: detect any emerging technological signature, assess its threat potential, and neutralize it. A von Neumann probe swarm is particularly terrifying because of its inherent scalability and autonomy. Unlike biological entities, they wouldn't require breathable atmospheres, liquid water, or temperate climates. They could thrive in the harshest environments, consuming entire asteroids, moons, or even gas giants for raw materials. Once launched, they would operate without oversight, their prime directive deeply embedded: maintain galactic order, prevent competition, or simply clear the path for their long-vanished masters. Their methods would be purely mechanistic, devoid of emotion or empathy, driven by cold, hard logic. The destruction of a nascent civilization would be merely a computational task, an input-output function, ensuring the long-term stability of the forest. Another terrifying prospect is that the cleansing force is not a single, unified entity, but an ecological imperative, a self-organizing phenomenon born from the very dynamics of galactic competition. Perhaps multiple ancient civilizations over eons independently arrived at the same dark forest conclusion. Each, out of fear and self-preservation, developed strategies for preemptive extermination. This would result in a decentralized, emergent immune system for the galaxy, where any new signal triggers a response from whichever silent hunter is closest and most capable. There would be no central command, no grand conspiracy, just a distributed, self-enforcing principle. Silence is survival, and any noise must be eliminated. The galaxy, in this view, is not ruled by a single emperor, but by a pervasive, ingrained paranoia. The motivation for such an ancient hunter doesn't have to be malevolent in a human sense. It could be purely pragmatic. Perhaps the resource demands of an exponentially growing civilization are indeed unsustainable, and the cleansing entity is a cosmic gardener, maintaining a delicate balance. Or perhaps it perceives a fundamental instability in certain types of technological civilizations, a tendency towards galactic-scale conflict or pollution, and acts as a preventative measure. This chilling thought suggests that the hunter might even be acting in what it perceives as the galaxy's best interest. A benevolent, from its perspective, custodian ensuring a cosmic peace by eliminating potential sources of disruption. Regardless of its precise nature, such an entity would possess capabilities far beyond our comprehension. Its methods of detection would need to be incredibly subtle, capable of spotting nascent technological signatures across hundreds or thousands of light years. This could involve advanced gravitational wave detectors, neutrino observatories, or even quantum entanglement communication networks, allowing for instantaneous information transfer across vast distances. Its methods of annihilation would also need to be efficient and decisive. We might imagine self-replicating berserker probes designed for planetary destruction, or even exotic weaponry capable of manipulating space-time, altering stellar processes, or inducing artificial supernovae. The goal would be complete eradication, leaving no survivors and minimal traces, thus preserving the overarching silence. The scale of its operation would be immense, stretching across millions or even billions of years. Its existence implies a terrifying resilience, having survived countless cosmic events and potential threats. It would be a force that has witnessed the rise and fall of innumerable stars, the birth and death of nebulae, and the slow, majestic dance of galaxies. Its perspective on time and life would be so alien, so vast, that the entire span of human civilization would be less than a fleeting thought. The thought of an ancient, hostile entity changes our cosmic loneliness into a profound sense of terror. We are not just searching for an answer to the Fermi Paradox, we are potentially trying to identify our executioner. The silence isn't just empty, it's the carefully constructed shroud woven by something that doesn't want to be known, a force that ensures it remains hidden by eliminating anyone who dares to break the quiet. This hunter's shadow compels us to look for its presence, not in overt aggression, but in the very absence of life itself. We must search for the fingerprints of its ancient unseen hand. If the cosmos is indeed a dark forest, silently patrolled by an ancient hostile force, then its most profound evidence would paradoxically be found in what is not there. The very absence of widespread intelligent life, the chilling silence that underpins the Fermi Paradox, transforms from a perplexing mystery into a potential fingerprint of the hunter's methodical work. We must learn to interpret the emptiness itself as a clue, to search for the echoes of an unseen cleansing, rather than waiting for a direct broadcast that may never come. The most glaring non-observation is the lack of visible megastructures. Consider the sheer energy demands of a civilization that has existed for millions or billions of years. Such an entity would almost certainly seek to harness the full power of its star. The hypothetical Dyson sphere, or variations thereof, where a star is partially or fully enclosed by artificial structures to capture its energy output, would be an unmistakable beacon. These constructs would drastically alter a star's infrared signature, radiating heat at wavelengths inconsistent with natural stellar processes. Despite decades of searching, astronomers have found no unambiguous evidence of such structures. While the occasional Tabby star, Keck 84628552, has sparked brief intrigue with its unusual dimming patterns, these anomalies have invariably been explained by natural phenomena. If an ancient, widespread civilization existed, or an advanced hunter utilized vast energy resources, the galaxy should be littered with such techno-signatures. Their absence could be a strong indicator of an active suppression mechanism. Furthermore, we see no evidence of widespread galactic engineering. If civilizations freely expanded and flourished, we might expect to see entire star systems deliberately moved, nebulae reshaped, or even artificial wormholes constructed for efficient travel. The universe, to our telescopic gaze, appears largely pristine, governed by natural astrophysical processes. While the sheer scale makes detecting subtle modifications difficult, anything approaching galactic-scale terraforming or resource extraction should, over billions of years, leave indelible marks. The uniform distribution of stellar populations, the predictable evolution of galaxies. These observations, while comforting, could also be interpreted as a lack of interference, a galaxy kept clean by an unseen hand that removes anything that disrupts the natural order. Consider the distribution of habitable worlds and the potential for life. Our understanding of planetary formation and stellar evolution suggests that life should be abundant. Yet, the Drake equation, though a statistical exercise, points to a potential disconnect between the number of planets capable of supporting life and the number of civilizations we can detect. If the cleansing force is effective, it would systematically target any world showing the telltale signs of emerging technology. This means that we wouldn't just find lifeless planets, we'd find planets where life should have thrived and advanced, but mysteriously didn't, or where signals abruptly ceased. The extinct radio civilizations could be a signature of the hunter. Civilizations that reached out, only to be silenced forever. The hunt for anomalous techno-signatures is therefore not merely a search for alien signals, but a search for evidence of a cosmic struggle. If a civilization was targeted, its destruction might not always be perfectly clean. There could be lingering debris fields far beyond natural planetary formation, unusual atmospheric compositions indicative of catastrophic events, or even subtle gravitational anomalies from the remnants of vast alien fleets. Future, more sensitive telescopes, capable of analysing exoplanet atmospheres for industrial pollutants or detecting faint non-natural energy emissions, might inadvertently stumble upon the archaeological sites of extinguished civilizations. These would be silent monuments to the hunter's efficiency. The very uniformity of the galactic environment, the lack of truly ancient, hyper-advanced civilizations might itself be a clue. The universe appears to be relatively young in terms of complex life. If our premise is correct that we are among the first, and a hunter exists, then the hunter must be old enough to have predated us, but not so ancient that it has already transformed the entire galaxy into its own domain. Its job, then, would be to prevent the emergence of such advanced competition, maintaining a dynamic equilibrium where no single power grows too dominant. The fact that the galaxy doesn't appear to be a single, sprawling super-civilization's backyard could be because such an entity exists and ensures no other ever reaches that stage, or because it is the hunter that ensures no one else reaches its stage. Ultimately, searching for the hunter's fingerprints means radically re-evaluating our cosmic search strategy. It moves beyond passively listening for greetings and towards actively seeking anomalies, disruptions, and an absence that is too perfect. It implies that the most significant discoveries might not be the detection of a vibrant alien signal, but the chilling realization of why there are none. The universe's silence, rather than a void of possibility, becomes a canvas upon which the brutal efficiency of an ancient unseen force has been painted for eons. The real question isn't what we will find, but what we won't find, and what that absence truly means for the fragile, flickering candle flame of humanity. The Great Filter, a cornerstone of Fermi Paradox discussions, traditionally represents an insurmountable barrier to intelligent life, either in our distant past or our terrifying future. However, the dark forest theory radically reimagines this concept, transforming it from a static internal challenge into an active, external, and relentless force. In this chilling twist, evolutionary hurdle or a future self-inflicted wound, it is the ancient hunter, an ongoing cosmic mechanism of extinction that systematically prevents civilizations from ascending to a level where they could pose a threat. Imagine the Great Filter as a vast invisible net cast across the galaxy, designed to catch and remove any burgeoning technological civilization. Every time a species develops radio astronomy, constructs a spacefaring vessel, or begins to radiate detectable energy signatures into the cosmos, it snags itself in this net. The hunter, whether it be an ancient AI, a self-replicating drone swarm, or an emergent ecological principle, then acts as the hand that pulls the net, eliminating the nascent threat with precision and efficiency. This means that the silence we observe is not merely a consequence of the filter, but the result of its continuous operation, a galaxy perpetually reset to a state of quiet by this unseen force. This redefinition of the Great Filter has profound implications for humanity. It suggests that every observation of silence, every empty corner of the cosmos, is not merely an absence of life, but a testament to the hunter's success. Each star system that appears devoid of advanced civilization, despite having all the prerequisites for life, could be a battleground where a budding intelligence was extinguished. The vast expanse of the galactic disk might be littered with the remnants of these filtered civilizations, their potential erased before they could ever truly blossom. The Fermi Paradox then becomes an archaeological mystery on a cosmic scale, where the ruins are so thoroughly erased that only the silence remains. The insidious nature of this external filter is its continuous adaptive presence. Unlike a one-time event like an asteroid impact or a planetary climate catastrophe, this filter learns, evolves, and refines its methods. As emerging civilizations develop new technologies for communication or expansion, the hunter adapts its detection and elimination techniques. This creates a perpetual arms race, one that most civilizations are unaware they are even fighting, and one they invariably lose. This means that the technological progress we so proudly champion, from radio telescopes to warp drive concepts, might be precisely what makes us more visible and thus more vulnerable to this ancient external filter. Consider the terrifying thought that every potential signal from an exoplanet that abruptly ceases, every faint techno-signature that fades into background noise, is not a coincidence or a natural phenomenon, but the direct result of this external filter at work. The galaxy, in this view, is a carefully managed garden, where any growth that threatens the dominant species is systematically culled. The hunter is the gardener, pruning away the shoots of emergent intelligence before they can overshadow the established order. This redefines the concept of galactic colonization. It's not about expanding into empty space. It's about surviving a space that is actively hostile to newcomers. This interpretation also sheds a new light on humanity's current position. If we are indeed among the first to reach our current technological threshold as discussed, then we might simply be the next candidate for this external filter. Our signals, which have been broadcasting into space for over a century, are not just cries into the dark. They are the equivalent of a campfire lit in a dark forest, announcing our presence to unseen eyes. The Great Filter, in this context, is not something we might face in a distant future. It is something that might be actively observing us now, calculating the optimal moment to intervene, waiting for us to cross an invisible threshold of threat. The existential crisis this poses is profound. It means that the universe is not just indifferent to our existence, it might be actively antagonistic. The search for alien life is no longer a benign scientific endeavour, but a perilous investigation into a potential threat. And the answer to the Fermi Paradox, the reason for the silence, could be the most terrifying revelation of all. That the universe is silent because something ensures it stays that way, and we are merely the next in a long line of civilizations that have, unknowingly, stumbled upon its radar. This chilling thought forces us to ask, how do we survive, or even thrive, in a galaxy where the greatest threat to our existence is the very fact of our intelligent life? What strategies, both technological and philosophical, must we adopt to evade the unseen eye of this ancient, relentless hunter? If the universe is indeed a dark forest, and an ancient hunter enforces the cosmic silence, then humanity stands at a profound ethical and strategic crossroads. The question of whether to broadcast our presence, once a hopeful scientific endeavour, transforms into a chilling dilemma with potentially existential consequences. This is the Terran dilemma. Do we continue our attempts to communicate, to seek companionship, knowing it might be a death sentence, or do we retreat into absolute silence, forever isolated but potentially safe? For decades, the search for extraterrestrial intelligence, or SETI, has embodied humanity's optimistic yearning for cosmic company. Projects like the Arecibo message beamed into space in 1974 were explicit declarations of our existence, our location, and our technological capabilities. The underlying assumption was that any advanced civilization would be benevolent, or at least indifferent, and that the benefits of contact, shared knowledge, cultural exchange, a cure for cosmic loneliness, would far outweigh any risks. But if the dark forest theory is correct, then every such message, every stray radio signal from our planet, is not a friendly greeting, but a precisely aimed flare, revealing our position to an unseen ancient predator. This re-evaluation forces us to consider the concept of active CT, or messaging extraterrestrial intelligence, METI, with extreme caution. Proponents of METI argue that actively broadcasting increases our chances of detection, and that the rewards of contact are too great to ignore. They might also argue that any hostile civilization capable of reaching us would already know of our existence through passive observation, rendering our broadcast moot. However, the dark forest perspective counters that even faint passive signals betray our technological maturity. An active targeted broadcasts are an explicit invitation for attention, accelerating our timetable for potential detection and elimination. It's the difference between a distant glimmer of a campfire that might eventually be seen and waving a torch overhead to draw attention. The alternative strategy, concealment, seems intuitively safer. This would involve a complete cessation of all intentional interstellar broadcasts and even efforts to minimize our leakage radiation, the unintentional radio and television signals that have been spilling into space for over a century. This would be a monumental technological and societal undertaking, requiring global coordination and a fundamental shift in our relationship with technology. It would mean embracing cosmic isolation, forgoing the dream of open communication with other intelligences, for the sake of survival. But even then, absolute concealment might be impossible. The heat signature of our planet, the artificial lights visible from orbit, the industrial pollutants in our atmosphere, these might all be subtle clues to a sufficiently advanced observer. Furthermore, a strategy of concealment faces significant internal challenges. Can humanity, a species driven by curiosity and a desire for connection, truly embrace perpetual silence? The psychological toll of knowing we might be alone, not by chance but by necessity, could be immense. It would also create a profound ethical dilemma. If we gain knowledge of this ancient hunter, do we have a responsibility to warn potential future civilizations? Or does that itself become a dangerous broadcast? The very act of trying to protect ourselves could inadvertently put others at risk. Beyond broadcasting, the dark forest theory impacts our approach to interstellar exploration and expansion. If we are indeed being hunted, then any attempt to send probes to other star systems, or eventually to colonize other planets, must be undertaken with extreme stealth and caution. A von Neumann probe, designed to self-replicate and spread, could be perceived as a terrifying weapon by a pre-existing hunter. Our expansion would not be into empty, welcoming territory, but into a contested zone where our every move could trigger a response. This means developing dark fleet technologies, minimizing energy signatures, and perhaps even engaging in deception strategies to appear non-threatening or primitive if detected. The Terran dilemma forces us to confront uncomfortable truths about our place in the universe. It shifts our perspective from benevolent exploration to strategic survival. It demands that we consider not only the potential rewards of contact, but the catastrophic risks. Our very existence, our intellectual curiosity, and our technological drive become both our greatest strengths and our most dangerous vulnerabilities. The decision to speak or remain silent is not merely a scientific choice, it is an existential gamble, a decision that could determine whether humanity remains a fragile candle flame in the dark, or becomes another extinguished ember in the wake of an ancient, unseen force. This leads us to the critical crossroads of humanity's future, a precarious balance between curiosity and caution. The unsettling possibility that humanity is not just alone, but uniquely vulnerable as an early detectable civilization in a hostile cosmos, brings us to an unavoidable crossroads. Our current era is one of unprecedented technological advancement, pushing us to the precipice of true interstellar capability. We are developing faster propulsion systems, more sensitive observatories, and the initial blueprints for off-world colonies. Yet this very progress, once celebrated as our ultimate triumph, now takes on a darker hue. It makes us both more detectable to a potential ancient hunter and, simultaneously, more capable of understanding the profound dangers that might lurk beyond our solar system. This isn't merely a theoretical exercise. It's a stark re-evaluation of our role in the universe. If we accept the premise of the dark forest theory, then our current phase of development, often termed a Type 0 or Type 1 civilization on the Kardashev scale, is akin to a child learning to walk in a dense jungle. We are radiating signals, consuming resources, and slowly beginning to explore our immediate surroundings, all without a full understanding of the unseen eyes that might be watching. Our very technological adolescence, characterized by a burgeoning presence, could be precisely the threshold that triggers a response from an entity designed to maintain galactic quiet. The urgency of this realization cannot be overstated. We are at a pivotal moment where our capabilities are growing exponentially, but our cosmic wisdom is still in its infancy. For example, our capacity to analyze exoplanet atmospheres for biosignatures, a key goal of upcoming missions, is a double-edged sword. While it offers the tantalizing prospect of finding life, it also implies that a more advanced civilization could perform similar analyses on Earth, revealing our biological and technological state with unnerving precision. The ability to detect life elsewhere could mean the ability for others to detect us. Furthermore, our drive towards interstellar expansion, while noble and aspirational, might be inherently self-destructive if the dark forest holds true. The idea of sending self-replicating probes, or even crewed missions to colonize other star systems, assumes an empty, welcoming universe. But if every expansion is viewed as a threat, then our efforts to secure humanity's long-term survival by becoming a multi-planetary species could instead be the catalyst for our demise. Each new outpost, each distant beacon of human presence, would simply offer another target, further illuminating our trail for an ancient hunter. This cosmic predicament demands a profound shift in our scientific, philosophical, and even political approaches. Instead of merely asking what is out there, we must also ask what sees us, and what are the long-term consequences of our actions in the galactic arena. This calls for a new branch of astrobiology and astrophysics, one focused on threat assessment, on understanding the potential motivations and capabilities of non-human intelligences, and on developing strategies for strategic concealment and survival in a potentially hostile environment. It implies a need for global unity, for prioritizing long-term survival over short-term geopolitical squabbles, and for fostering a deep scientific literacy that extends beyond our planetary concerns. The challenge is immense. How does a species like ours, inherently driven by curiosity and a desire to explore, learn to navigate a cosmos where silence is safety and visibility is a liability? It might require us to reconsider the very nature of progress. Perhaps true advancement in a dark forest isn't about broadcasting our achievements, but about mastering the art of subtle existence, of becoming undetectable, of moving through the galaxy like a ghost. It might mean developing technologies not just for exploration, but for defense and stealth on an unprecedented scale, transforming humanity into a species that is both powerful and profoundly discreet. Ultimately, humanity's crossroads is a moment of existential introspection. Do we continue our optimistic search, risking everything on the hope of benevolent contact, or do we internalize the chilling implications of the dark forest, embracing a future of strategic caution, quiet observation, and perhaps a solitary but secure existence? The answers we choose will not only define our place in the universe, but will determine if we are indeed the first, and perhaps the very last, civilization to shine so brightly in this particular cosmic night. The universe, in this light, is not just a stage for our grand ascent, but a dangerous arena where our continued existence depends on understanding the true nature of its silence. The cosmic silence, once a grand, enigmatic canvas for our hopes and dreams of interstellar companionship, now whispers a far more terrifying truth. Our intellectual journey through the Fermi Paradox has twisted its meaning, transforming a question of absence into an agonizing inquiry of active suppression. We've moved from the comforting, if lonely, thought that the universe might be empty, or that advanced civilizations simply self-destruct, to the chilling realization that the quiet is meticulously enforced. The profound silence is not a void of possibility, but a meticulously maintained shroud, woven by an ancient, unseen force that views any nascent flicker of intelligence not as a kindred spirit, but as an inevitable threat. This paradigm shift profoundly redefines humanity's place in the cosmos. For generations, we saw ourselves as latecomers, arriving after countless millennia of cosmic evolution, hoping to join an established galactic community. But a detectable technological threshold in our galactic neighbourhood, then our uniqueness becomes a profound liability. We are no longer merely seeking fellow travellers. We are, by virtue of our very emergence, an anomaly that triggers a response from something ancient and powerful. The romantic notion of cosmic loneliness has been brutally supplanted by a gnawing existential dread. The chilling understanding that our fragile light in the dark forest of the universe has already drawn attention. The very concept of a great filter has been reshaped from an internal challenge that civilizations must overcome to an external, relentless mechanism of extinction. It is not an abstract evolutionary hurdle, but a cosmic sentinel, an active force that has, for eons, pruned the blossoming shoots of intelligence across the galaxy. Every star system that appears devoid of advanced life, despite harbouring conditions ripe for its development, could be a silent monument to this hunter's efficiency. The absence of widespread megastructures, the lack of ubiquitous techno-signatures, the unbroken quietude across billions of stars, these are not merely unexplained mysteries, but potentially the clearest fingerprints of an entity that ensures no other civilization can rise to challenge its ancient dominance or disrupt its established order. This ancient hunter, whatever its true form, transcends our anthropocentric notions of good and evil. It might not be malevolent in the human sense, but purely pragmatic, a cold, logical extension of an imperative for self-preservation, or perhaps even a cosmic stewardship. Whether it is a super-advanced, self-replicating artificial intelligence, a decentralized network of autonomous probes, or an emergent property of galactic competition, its existence implies a terrifying resilience and an incomprehensible scale of operation. Its methods are silent, swift, and thorough, designed to eliminate potential threats at their earliest, most vulnerable stage. The destruction of a burgeoning civilization would be a calculated maneuver, an ecological necessity in a universe where unchecked growth is perceived as a universal pathogen. This profound realization throws humanity into a precarious, unprecedented position. Our accelerating technological prowess, our relentless drive to explore, to communicate, to expand beyond our home world, suddenly takes on a perilous new meaning. Every radio wave we broadcast, every probe we launch towards distant stars, every colony we envision on other worlds becomes an increasingly visible beacon in the dark forest. Our technological adolescence, once seen as a triumphant march towards cosmic maturity, is now recast as a dangerous exposure, an unintentional declaration of our presence to an entity that may have patiently awaited precisely this moment. The Terran dilemma is therefore not an abstract philosophical exercise, but an immediate existential choice. Do we continue to shout into the void, hoping for a benevolent response that may never come, risking annihilation? Or do we, with profound and perhaps heartbreaking resolve, choose absolute silence, adopting a strategy of cosmic stealth and isolation, accepting that our journey through the stars must be one of profound discretion? This choice demands a level of global unity, foresight, and humility that humanity has rarely demonstrated. It requires us to move beyond our tribalistic squabbles and recognize a singular, overarching threat that dwarfs all others. Our understanding of science itself must adapt. The search for extraterrestrial intelligence can no longer be purely about discovery and communication. It must become a discipline of cosmic threat assessment, of understanding the subtle clues of galactic ecology, and of mastering the art of survival in a universe where the ultimate predator. We must develop technologies not just for exploration, but for profound concealment, for defense against the unimaginable, and for a strategic understanding of the cosmic currents that govern the rise and fall of civilizations. This new cosmic wisdom may be born not from wonder, but from a profound and necessary fear. The universe, in this chilling light, is transformed. It is no longer merely vast and indifferent, but actively hostile to nascent life that dares to announce itself. The stars, once symbols of infinite possibility, become watchful eyes. The silence, once a symbol of cosmic loneliness, becomes the terrifying sound of a maintained order, a constant vigil against any new noise. Humanity is left to ponder the ultimate paradox. Our intelligence, the very faculty that allows us to comprehend this terrifying reality, is also the trait that may have painted a target on our back. The question then ceases to be, are we alone, and morphs into a far more urgent, desperate query. Are we already seen? And if so, how do we, a fragile young civilization, defy the ancient, ruthless logic of the dark forest? How do we ensure that we are not merely the first to awaken, but also the first to survive the hunter's shadow? Our future is not merely about reaching for the stars, but about understanding the profound, dangerous meaning of the silence that has always surrounded them. The greatest wonder in the universe may not be the existence of alien life, but our own struggle to exist in a cosmos that might be actively conspiring against it.